Okay, so what we're going to do today, we're going to take a few notes on the section, what are we on, 9.1. The stuff that we're doing in the homework today is finding points of intersection using analytical methods. So not graphing. I'm not going to ask you to graph in the homework today. Is that door locked? Sorry, just locked out Evan. Don't worry about it. Sorry, I didn't realize the door was locked. All right. Anyway, we're going to be finding points of intersection using analytical methods. So using that kind of that method for completing the square and kind of using that to go one step further. So without graphing. So that's a big thing. So I got a couple problems picked out. I have two problems. And so what we're doing is finding points of intersection between parabolas and linear functions. So I'm going to write this here. So again, we're going to be using a parabola and a line and finding that point of intersection. So that's kind of our goal today, without graphing. So figure out this. This is kind of the main thing here. Can we do this without graphing? Without, checking Desmos and seeing whatever they say and actually, providing work and all that good stuff and seeing how it comes out. I think in the homework today, you'll have 5 problems. That's it, 5. I made them myself, so. I kind of want to see where you come up with. They're going to be decimals. They're not going to be clean numbers or anything like that. Usually when lines and parabolas meet, they're going to be at some weird location. We're going to look at that today. I got 2 that I like to do, and then I'll turn you loose on homework. And so it'll go live. You'll submit it. It's going to be due tomorrow, which I know is kind of a short turnaround, but you're going to have plenty of time because tomorrow I know we're on a weird early out schedule tomorrow, so you should have plenty of time. I'm going to give you time in class to kind of work on it. So. I think I only have you for like 18 minutes or something like that tomorrow, some weird number. So I'll give you time to work on it. So, all right, we ready to go though? Everyone's got notes out, everything? Okay, let's take a look. I got a couple problems here picked out. So here's the first one that I want you to have written down somewhere in your notes. So y equals, this green is terrible, x squared plus 8x. That's gonna be my parabola. Now how I know that's the curve, it has a power on it. Anytime you have a power greater than 1, so like a 2, it's gonna have a curve now. That's the introduction, and it's going to turn 1, so it's going to actually be a U shape. It's going up. That's how I can kind of tell. So it's got a minimum value, and then the line that we're going to have cross it, the linear function. I'm going to get away from this green. The green is really not very good. The linear function I want to have is y equals negative x plus 3. Okay, that's a linear function. And it's it's kind of tilted downwards. It's tilting down to the right. It's got a negative slope on it, starting at positive 3, but it's tilting down. So kind of giving you a rough sense of what this thing looks like. It probably looks something like this. Let's see, that's hitting 0 and negative 8. 0 and negative 8. And so this thing is looking something like this. That's my parabola. Again, how I did that, I know the bowl goes up. It has power 2. Positive number up front. If I factor that thing apart, the x-intercepts are 0 and negative 8. And then the linear function starts at 3, and it's going down 1 over 1. So it's going to look something like this. So you can definitely see they are going to cross at 2 locations. That's the goal. Can we figure out where they cross? It's going to be somewhere up in the air, over here, maybe to the right of 0, and then somewhere up here above, 0, pretty far up. And that's what our goal is, to figure out where they meet. Okay, questions on what the goal is today. Now again, I'm not going to have you draw things today. That's not the goal. I just want you to get a sense for what we're doing. But now, let's actually talk about the means of how do we do this. The trick that I talked about yesterday is you set them equal to each other, whatever the equations are. So that equation, this equation, they already have the y's. We're looking for where the y's are the same. So we set those equal, okay? So we're going to set that x squared plus 8x, and I'm going to set that, whatever that parabola was, I'm going to set it equal to that linear function. I don't care what the equations are. Okay, so here we go. We set them equal to each other because these should be the same y number because I'm looking where they meet. And now all we have to do is complete the square. And when we complete the square, it gives you your 2 x's. The 2 x's in my case, once I complete the square, isn't going to be where it hits the x-axis. It's going to actually be where they meet, where they actually touch. And that's the goofy thing. That's the thing that a lot of people don't understand, is that we're actually finding the exact locations where they actually meet. That's kind of a rare thing, and then you don't see that too often. So that's what we're going to be looking at. So I'm going to move this x over. So if I move this x over, it becomes a 9x. So x squared plus 9x equals 3. If there's any number in front of the x squared term, I'll have to factor that out. I don't have to do that because that's how we complete the square, right? We have all the x's on the left side, the numbers on the right side. We have to take half the middle squared. Well, the middle term is this. What is that, 4.5? 4.5? We have to square 4.5. 4.5, what are we going to be in, like the 16 to kind of 20 range? 4 times 4 is 16, so it's giving me that ballpark. I don't actually know what the number is. I gotta type it in my calculator number. Maybe these problems up. 4.5 squared. 20.25, so yeah, it's a decimal, that's fine. So that's half the middle squared, so 20.25 plus 20.25. All right. Half the middle squared. Now, if there was a weird number out front, half the middle squared times the number out front, then you add that number across, whatever it is. You'll see that in the next one. I'll kind of have a weird number out front. I think I put a -1 out front or something like that. All right, so now we complete the square by factoring, doing all the weird stuff that we've been doing the last couple days in here anyway. You factor this left side up. It's always half the middle. So that's kind of the easy part. You don't even have to think about it too hard. It's always half the middle. On the right side, I'm going to get 23.25. And now what we have to do is solve for x. This is where the part where this is how we completed a square earlier. This, I know we can read off where the vertex is. I don't want to know that because that doesn't help me here. What I need to know is what are the x's, where these things cross. So to solve for x, you have to take the power of 2 to the other side and do a square root. So that'll be plus or minus whatever the square root of 23.25 is. That'll be some weird decimal, it's fine. That's how you take that. And so when you take that power of 2 to the other side, that square, it became a square root. That was the inverse operation to the other side. Then I just need to get the x by itself. So I'll drag the 4.5 across and subtract it. So this will be, if I move that 4.5 over, it'll be -4.5 plus or minus that square root. Now, on a calculator, I need to know what that square root is. The square root of 23.25, is that 4.8? 4.82 roughly, if I kind of ballpark it. I'm going to go about 2 decimal places. I don't need to go too much further than that. We're not finding exact answers, we're just getting close. Okay. Now, what this represents, now that we've completed the square, those two numbers, so -4.5 plus that and then -4.5 minus, that represents the two x's where these things actually crossed. These locations, the x numbers where I actually met. The x's, not the y numbers, the x numbers where they met. So if I actually do the math here, -4.5 plus 4.82, I'm getting 0.32. So that's 0.32, and if I subtract them, so -4.5 minus 4.82, so -4.5 minus 4.82, I'm getting -9.32. Those are the two x's where I'm going to meet. And again, that's the coordinates here. This coordinate should be 0.32 comma something, right? And this coordinate up here is -9.32, is that what it was? Comma something. I'm getting the x's. Okay, questions so far? Notice, I haven't went like drastically like different ways of doing this, right? I'm sticking with the same method we've been learning in the last unit, right? If you think back to the last unit test we did a lot of completing the square. We used it to find, where the vertex was, that lowest point, the minimum. We used completing the square to figure out where it hits the x-axis a couple times. We figured out how to use this process to figure out the focus and directrix and all that. That'd be an interesting question. Where does the directrix hit a line? That'd be interesting. I'll keep that in mind someday. All right. Anyway, questions on how I find the x's though? Okay, that's probably the most time-intensive part of the homework. You have to do all that work and write it down, right? You're not graphing, you're just doing that. Now, the last step is I have to find the y numbers, because the whole point is to find the coordinates, right? That's what I want submitted to me on, the Google Classroom for each of the questions. You'll submit the coordinates where they met, and give me about 2 decimal places. So I have the x's. How do I find the y numbers?
Plug it into the original problem.
Exactly. Whatever the original problem was, you're going to take these numbers one at a time and plug it back in, just like you said. Apologies. Okay. Anyway, sorry. So I'm going to take those x's and I'm going to plug them in. And I would probably recommend just go up here and plug them in here. I know it seems weird. I would just plug into one of the 2 originals. It doesn't actually matter which one you plug it into because we're finding where they both met. They're going to be the same coordinate no matter what. And it's going to be close because obviously I'm like rounding these decimals off. Like that square root of 23.25. That's a very like irrational number, right? That thing went on for ever. So I just ballparked it what it was. So 0.32. If I plug that in, so I'm gonna use this equation. This is the equation I like. So negative 0.32 plus 3. If I plug that number in, it spits out my y answer. So again, negative 0.32, because again it was 0.32. I plugged it into the negative x, add 3 to it. I'm getting 2.68. So this is 2.68 up in the air. Yeah, okay, fair enough. Looks okay. Looks about right. And then I'll plug in the negative 9.32 in here. So negative 9.32 with a negative sign in front will make it positive 9.32. And we add 3 to it, so that's what, 12.32 up in the air? Okay, yeah, that makes sense. Now, just to prove my point, I already graphed these, right? I went on Desmos earlier today, because I created these problems earlier, just kind of made them up. I went on Desmos and I typed it in the graph just to see if my answers are correct. I like to do that every now and then. I think it's a smart idea. I know that I'm enabling people, like if you're gonna just avoid all the work, I wouldn't avoid the work, work on these. At least you have Desmos to check to see if you did it right. So, but does everyone understand the coordinates I used? How we did it? We're gonna do one more of these. I'll do one more, and I'll do one where the graph is kind of facing weird directions and whatnot. So, okay, but we're good though? Okay, I'm gonna get rid of that so I can put up the graph, if you guys don't mind. Yeah? No one needs it? Okay, all right, I'm gonna pull up the graph here from Desmos. All right, so there we go. I graphed these earlier. So here's the graph. If you can't see that, this is the curve right here. There's the curve. It hit 0 and negative 8, as you can tell. That was the line. It was hitting 3, and it was kind of going down over 1. There's the line. And these are the coordinates where that was in question. I clicked on each one, and then, on Desmos, when you click on it, it tells you the coordinates. So I clicked on this one first, and then what I did is I just kind of super zoomed in on what it was. So there it is. Not bad. There's the coordinate. Now, they had more decimal places than me. I just want 2. Okay. And then I clicked on the other one. So when I went back over here, I clicked on this one to see where that coordinate was. And there you go. So, not bad, right? So that's what I expect to see. I don't want to see, their coordinates that they provide you. That's fine. I want about 2 decimal places. I want to, make sure you're doing the work on papers, you're completing the square and all that good stuff. The numbers work. The method I'm showing you is a very valid method of doing this. It's just it's time intensive. I know, that's why I'm only giving you 5 of these. So, okay, let's do one more. I'll be done hopefully in the next 5 minutes. I'll give you plenty of time to work on your assignment. And plus I'll give you time tomorrow in class to work on it too. It's due tomorrow, so keep that in mind. It's due by 11:59 tomorrow. You'll submit it on Google Classroom. So, all right, let's do another one. Get rid of this. All right. Let's do it. What is my projector doing? Doesn't want me to put that thing away. Go away. I don't want that thing up there. All right. What's it doing? All right. That was odd. Okay, well, you saw the graph like 15 times. It just kept popping up. Just when you just see that graph. All right. Last one. This is my last one today, I promise. All right, so here we go. We have y equals negative 3x squared plus 6x. So again, that's it is a quadratic. It is a parabola. It's actually facing down. The reason being it has a negative number out front. And I did promise you you'd have a negative number, and I put a digit out front so you could experience that when you have a number, a leading coefficient out front. It doesn't have to be negative. I just put a 3 out there. But this one's actually facing down. My line where that we're actually going to be meeting is y equals 2x minus 8. So that line is really far down on the x-axis. So really far down. So let me show you what I'm talking about here. So now it doesn't want to pop up. All right, there we go. Okay, so there's the curve, as you can see. You know, it's the parabola. It's facing downwards. This is the line. It's starting at negative 8 down here, down the road. It looks like it's hitting negative 10. Oh, no, it is. It's hitting negative 8. That's negative 10. That's negative 8. And then it's going up 2 over 1. So you are actually seeing where it's actually meeting. So you're kind of seeing these coordinates where it's actually crossing. So it's going to hit twice, as you can tell. I can kind of ballpark those coordinates, and we're going to kind of see what they are. You know, just kind of looking. Looks like each one of these hash marks is 1. So that's 1, 2, about 2.5. So 2.5, comma 1, 2, 3 down. So that's kind of ballparking that. This coordinate over here looks like it's 1 over negative 10 down, so negative 1, negative 10. That's the coordinate that looks. This is what I'm going to try to show. I'm going to try to show that these kind of look like the coordinates. All right, that was a pretty accurate drawing. So hopefully my dots are in about the right spots. So again, we're going to do the exact same math. Again, it's nice when you have Desmos or Wolfram Alpha or whatnot. So that you can actually kind of tell, you can kind of check your answer. It's kind of nice to know if you're doing it right, if you have the right numbers, or in the ballpark. Again, don't just copy theirs. Actually show, do some of the work on your paper and stuff. So, okay, are we good to go? We know what we're going to try to find here. We're going to try to prove that, or at least get close to those, because again, I'm ballparking by just looking at a picture. Okay. Okay, so let's do the numbers here. So again, the process, you set these two things equal to each other. God, that green is terrible. Get out of here. All right, so we're going to set these things equal. So negative 3x squared plus 6x, I'm going to set that equal to the other equation, whatever it is. Set them equal. We're going to complete the square, so that means I need to move all the variables to the left, numbers to the right. So I need to move the 2x over. What happens when I bring the 2x across? Subtract, right? It's got to subtract over. So this is going to be a negative 3x squared plus, what is that, 4x? Okay, we have a negative 8 over there. Okay, and this is going to be a really bad number. I'm going to use decimals here, just so you get to know how to do it when you have decimals for yours. Because yes, at some point you'll have to deal with decimals. They're going to happen on these things. So I tried to provide you with one here. Has decimal. Okay, are we good with the setup so far? I know I'm going kind of fast, sorry. Okay, so what I'm going to do next. Now, part of the completing the square, I know you're trying to think, oh, or just take half the middle square. No. We have to get rid of this negative 3 first. Not divide everything by negative 3, don't do that. We have to factor it out. So I'm going to pull this negative 3 out of the parenthesis that's over here. I'm going to leave this negative 8 alone. I don't really care about it for right now. When I divide this negative 3 out, okay, this x squared turns positive, and then the 4 divided by a negative 3 is going to be negative 1.3 repeating. I'm going to put a decimal there. 2 decimal places. Again, how I got to that, it was 4 divided by -3. Okay, does that make sense so far, what I've done? Now that we have my numbers, right, because I factored out that -3, right? Now what we're going to do is we're going to take half the middle squared. So again, 2 decimal places. Half the middle of this, so 1.33 divided by 2. Okay, that's this number when I divide by 2 is 0.66 or 0.67 if you round it. And then we have to square it. So half the middle squared, so half of that squared. So we get about 0.44, half the middle squared. And so that number goes here, right? I'll put it in a different color. So half the middle squared, I'm getting about 0.44 roughly. Now you have to take that number times the number out front, and then that's what you're going to add to the other side. So 0.44 times -3, and that's what I'm putting over here. So -1.32. Okay, do we understand so far? Okay, now again, I'm going about 2 decimal places and my rounding's off compared to yours. Sorry, I'm just using the calculator, just kind of rounding it. Half the middle squared, took it times the number out front, and that's how I got that number. Okay, I haven't lost anybody, have I? Okay, so now this side factors apart. This half the middle ends up being 0.66 or 0.67-ish. That's half the middle. We still have the -3 out front, and then over here we have the -9.32. Okay, then I just have to solve this thing. I have to, solve for x. Okay, now this is the part I kind of warned you of, right? Decimals, you add gross in it. There's a leading number out front, correct? We have to get rid of the leading number out front first before you attempt to take the square root to the other side. Okay? Why should I get rid of this -3 before I attempt to take the square root? What would be the main reason? What happens if I took the square root to the other side?
You couldn't do that.
Exactly. I couldn't do it, right? You can't take the square root of a negative number. So we have to divide the -3 off first. So I'm going to take that -9.32, so -9.32, and I'm going to divide by -3. So when I divide this -3 across, because again, this is being multiplied on the front, so I'm going to divide it over here. That'll end up being positive on that side. So it ends up being a positive 3.11. Ends up being a positive 3.11. It was 3.10, but there was a bunch of numbers after it, so I just kind of rounded it up. So divided it over. And now we take the square root and we go from there. Right? You take the square root to the other side. So it's plus or minus whatever the square root is. And then I'll add that number across. So this will end up being x is equal to 0.66 plus or minus, now the square root of 3.2, the square root of 3.11, 1.76 roughly, if I round it really poorly. So you add those numbers, you subtract those numbers, and you get your 2 x's. So the 2 x's we're going to have, so 1.76 plus 0.66 is 2.42. 2.42. Oh, that's a terrible 2. 2.42, and the other one is .66 minus 1.76. That makes it negative 1.16. And yeah, those are actually really close to the x numbers I said it was going to be. Okay, I said my x number is going to be around 2.5. I said my x number on this one was going to be about -1. That's pretty close for a guess. Just looking at the graph and kind of guessing at it. And then what do I have to do with those numbers? Plug it back in. I always recommend when you plug them in, go always to the linear equation. It's the easier of the two. Plug them back in here. Don't waste your time on the quadratic. That takes too long. So I would take those numbers one at a time and plug it into this thing. This is my linear equation, the original equation like we said earlier. Plug those numbers in here. So 2.42, if I plug that in, right, subtract the 8. So 2 times 2.42, and then we're going to subtract 8. I'm going to get 2.42. This is going to end up being -3.16, which I said it was going to be about I said it was going to be about 3. I should have said -3. I'm an idiot by just looking at the graph. And so that was pretty close. If I put a negative number there, should have known it was below the x-axis. Duh. And the other one, if I plugged in the -1.16 instead, so 2 times the -1.16 and subtract 8, I'm getting -10.32. Really close numbers I was looking at the graph. Now again, just like always, I went on Desmos earlier. I typed this in, because again, I just made this problem. I typed it in, I just want to see if my coordinates were correct. See if I'm getting in the ballpark of what I kind of estimated here. And so I clicked on the left one first, clicked on this dot. I said this was going to be about -1, -10. So here it is. There it is. So it said -0.09 on the, but again, all my rounding was kind of off. And then -10.19. So pretty close. Again, this is where, by doing 2 decimal places, you're going to be slightly off from what Desmos says. So I do want you to do it by 2 decimal places. I don't mind that you're off a little bit from Desmos. You're in the ballpark. Okay? And the next one, -2.4 and 3.1. So that one was probably a little more accurate on the other side, for rounding anyway. Okay, questions? Okay. Google form has already been submitted to you, so you have plenty of time. Go look it up. There's 5 questions. Provide you the equations. Do the work on a piece of paper. Submit your answer as coordinates. This is what I want you to submit to me. I want the coordinates where they cross. 2 decimal places when you do it. And yes, your decimals will be probably different compared to Wolfram or compared to Desmos. The reason why, if you start rounding 2 decimal places everywhere, you'll be slightly off in every spot. So they went as many decimal places they could to get those numbers. So, all right. But there you go. That's it for